Welcome to this explainer. Today we're diving into a massive historical paradox presented in our source material. And honestly, it's a mystery literally etched into some of the hardest stone on Earth. We're heading straight to the Giza Plateau and the Aswan Quarries to explore what researchers are calling the Granite Enigma. As someone who loves digging into the past, I find the arguments presented here absolutely fascinating, mostly because they ask us to completely rethink accepted historical narratives based on some very specific physical anomalies. Let's get into it.
So, picture the scene. The sun is setting over the Giza Plateau, and it's casting these long, dramatic shadows over massive, incredibly hard granite sarcophagi. The sheer scale of these stones is just immense. But getting up close brings up a fundamental, almost mind-bending question. Mainstream history tells us that ancient workers carved these colossal structures using primitive copper chisels. But here's the catch. Copper is a notoriously soft metal, right? So how exactly could ancient workers achieve absolute mathematical perfection in incredibly dense granite using only primitive soft tools? Well, let's look at the physical data our sources have compiled.
Section 1. Exhibit A. Impossible flatness. Starting our macro-level investigation right here. When we examine highly detailed scans of these Aswan granite blocks, we aren't just looking at rough-hewn stone. Our sources point out perfectly flat planes that meet at exact razor-sharp 90-degree angles. Now, think about trying to carve the inside corner of a hard stone box with a handheld chisel. Naturally, the corner's going to round out. You just can't get it perfectly flush. Yet researchers note that these interior corners are incredibly sharp, which completely defies the known capabilities of the handheld primitive tools supposedly used to create them.
And it's brilliant how modern engineers actually verify this anomaly. To physically demonstrate the stone's flatness, they use modern visual aids. Step 1, they place a modern, machined precision square directly against that ancient interior corner. Step 2, they perform a light gap test. This is where you shine a brilliantly bright light right behind the square. Now, if the stone surface is uneven by even a microscopic fraction, that light is going to bleed through the gaps. But here, the light is entirely blocked. According to these tests, the stone possesses a level of flatness that easily passes modern engineering standards. It's wild.
Section 2. Exhibit B. The fingerprints. Moving down from the macro level of giant blocks to the micro level, the sources highlight something machinists call feed marks, found in high-definition macro shots of the granite. By definition, feed marks are the distinct, circular striations and grooves left on a material's surface by the cutting edge of a machine tool as it moves along. You simply do not get perfectly parallel, evenly spaced circular striations from a worker randomly hitting a chisel with a rock. The argument here is that these marks strongly imply a true mechanical consistency. And the sources argue the evidence actually goes even deeper, literally pointing to spiral grooves embedded deep inside hard granite cores found at these sites. When you examine the footage of these cores, the spiraling grooves wrap around the cylinder of stone with absolute mathematical precision. In our modern manufacturing world, these exact types of grooves are identical to the cuts made by high-speed tube drills biting rapidly into hard material. The really crucial point made by these researchers is the side-by-side comparison. On one hand, we look at 3D animations of what modern industrial CNC machining and diamond-tipped drilling produce today. And then we contrast that directly with the ancient granite spiral grooves and feed marks. The visual match highlighted by the data is striking. The ancient marks bear all the identical hallmarks of modern, high-speed, diamond-tipped industrial drilling. It's a fascinating direct comparison of modern capability right up against ancient physical reality. Section 3. The interrogation. Challenging the narrative. Having seen the physical evidence on both the macro and micro levels, we are left with a pretty stark contrast. On one side, we've got the standard mainstream narrative, the archaeological illustrations we all saw in textbooks, depicting workers chipping away at massive stones with handheld rocks and primitive copper chisels. But on the flip side, the sources present this hard physical evidence, distinct signs of advanced machining, exact 90-degree interior angles, light gap verified flatness, and high-speed tube drilling. These two concepts just simply do not match up. And this glaring contradiction brings us to a massive technological gap. If the physical evidence clearly points toward advanced machining, we have to ask the obvious question raised by our sources. Where are the missing tools? What happened to the sophisticated machinery, the high-speed drills, and the precision instruments that would have been absolutely required to achieve such mathematical perfection in solid granite? Because as of right now, absolutely nothing matching that description has been found in the archaeological record of the era. Section 4. The Unsolved Case. A Lost Industrial Past.
So, let's treat this like an unsolved case. Here is our final dossier summarizing the most compelling evidence we've covered in this explainer. The sources point to mathematical symmetry with perfect 90-degree interior angles. They show surfaces that flawlessly pass modern light gap flatness tests. We've noted the circular striations and feed marks right alongside those spiral grooves indicative of high-speed tube drilling. And remember, all of this is executed on an immense scale, carved into some of the absolute hardest stone on the planet. Looking at the historical timeline, the accepted dates for the Giza construction fall roughly around 2500 BCE, which follows the unification of early dynastic Egypt around 3100 BCE. But the researchers argue these machine marks invite us to consider completely different possibilities. Could this evidence actually point to a hypothetical, pre-dynastic, high-precision civilization dating all the way back to 10,000 BCE or even older? The physical anomalies on the stone certainly open the door to exploring that incredibly fascinating timeline. Looking closely at this perfectly machined ancient granite interior, I want to leave you with this final thought. Based on the sheer precision and the tool marks presented in our sources, are we actually looking at the surviving fingerprints of a forgotten industrial age? Is it possible our technological past is far, far more complex than we've ever been led to believe? It's a profound question, and honestly, the stone itself seems to be demanding an answer.